Hi guys, it's been long. I just felt like I should talk to you, that I should do something. Yeah, it's been like I don't know how many weeks I've not made any video, so I decided just to do a practical question. I have a quadratic equation here. S of t is equal to minus 2t squared plus t plus 1. Actually, this is a quadratic function. For t is greater than 0. Okay, now this is in any calculus. I mean, after you have learned how to do differentiation and integration, now there are some application of calculus. So I have this equation. So let's say the motion of a particle, which we don't know, we take a particle, okay, a moving particle. So let's suppose the motion of a particle is given by s of t is equal to minus 2t squared plus t plus 1 for time greater than 0. Okay, now this particle is moving in a parabolic motion, okay, because it is modeled by a quadratic equation. So if we're to plot, we are going to have something like this, okay, and this axis is time, okay, and then this is s, okay. So this is actually the distance and this is time, okay. So now this particle is given by s of t is equal to minus 2t squared plus t plus 1, okay, for time greater than 0, okay, this side. So we know that this particle will be moving in this direction and it's gonna cut at 1, okay, yes, it's gonna cut at 1 because the intercept is at 1. So this is the motion of a particle, okay. So now let's find the distance traveled at time t is equal to 1, okay. So at time t is equal to 1, what's the distance? So we just say s of 1 is equal to minus 2 1 squared plus 1 plus 1. Then we have minus 2 plus 1 plus 1. This is equal to 0, okay. So at time is equal to 1, there is no distance traveled, okay. At time is equal to 1, there is no distance traveled because actually time is greater than 0, okay. Time is greater than 0. Now time is greater than 0, but when time is 1, we know that the distance will be 0 because according to this equation, the distance of a particle will be 0 when time is 1 second. So now the other thing is, let's find the length traveled from 1 to 4, okay? From 1 to 4. Let's suppose we have 1 here, okay? And then we have 4 somewhere here. We have 4 somewhere. Okay, let's say we have 4 somewhere, okay? I don't know. I'm just supposing that's where 4 is. Now, let's find the distance traveled, okay? Let's find the distance traveled from time is equal to 1 to time is equal to 4. So to find the distance, we take the integral from time is equal to 1 to time is equal to 4, okay? 1 to 4. Then we need to find the norm, okay? Then t. This norm, okay? The norm that is here, okay? We are going to take the derivative of s of t. When we take the derivative of s of t, here we are finding the norm r, okay? So this norm r is equal to s prime of t, okay? And this is equal to, this will be, since the function is minus 2t plus t squared plus t plus 1, so the derivative will be 2 multiplied by minus 2, which is minus 4. Then the derivative of t is 1, okay? So plus 1, this will be minus 4t, okay, plus 1, okay, minus 4t plus 1. And then the derivative of 1 is 0, okay, because the derivative of a constant, okay, is 0. So this is, so we have found norm r. Norm r is minus 40 plus 1. So now let's find the distance traveled from time is equal to 1 second to 4. So the distance will be given, length is equal to the integral from 1 to 4 norm with respect to t. So this is 1 to 4. Then here, what is this? It's the derivative is minus 4t plus 1. Minus 4t plus 1 dt. Now this is a simple integral, okay? This is a simple integral. When we integrate it, we are going to have minus 4t squared over 2 plus t. Now we are integrating from 1 to 4. Then, of course, 2 goes there. We remain with minus 2t squared plus t from 1 to 4. Then minus 2, 4 squared plus 4. Then minus 2, 1 squared plus 1. Then here we have minus 2 by 16, then plus 4, okay, plus 4, minus 2 plus 1, okay. Then here we're going to have minus 32 plus 4 minus 2 plus 1, it is minus 1. So this is gonna be minus 32 plus 4, it's gonna be minus 28, then plus 1, this is minus 27. So now the distance traveled is, length is minus 27, okay? Why is it minus 27? It means that this particle is decelerating, okay? It is not accelerating. From 1 to 4, the particle is decelerating, okay? So it's the distance is reducing, okay? So when you look at the graph, okay, the graph from this side to this, from this side until it reaches this side, it is increasing, okay? Then from 1 going to infinity, it is decreasing, okay? So the distance here is decreasing. So the particle moves minus 27, okay, units in decelerating, okay, deceleration. So that's the distance moved from time 1 to 4. Then we have another question, the velocity of a particle when time is equal to 0, okay? Find the velocity of a particle when time is equal to 0. So the velocity of a particle or the velocity of a body is, velocity is given by, average velocity is given by dv dt, okay? It's given by dv dt, that's the average velocity. So actually not, I made a mistake. It's given by ds dt, okay? Okay, ds dt, change in the distance over change in time. Okay, that's the average velocity. Okay, so since we have the equation, which is st is equal to minus 2t squared plus t plus 1. So the average velocity is ds by dt. So we just take the derivative, which we took. It is minus 4t plus 1. Now the velocity at time is equal to 1. Okay, at time is equal to 1. The velocity is plus 1. This is minus 4 plus 1, and this is minus 3. Again, when you look at the movement of this particle from minus infinity to 0, when you look at this motion, it is accelerating, it is increasing up to the maximum point. It is accelerating, and then it will decelerate. Okay, so since at time is equal to 1, it is decelerating. It is not increasing. So the velocity is in negative. Okay, a negative direction. Okay, so it is minus 3 meters per second because the particle is decelerating. Now let's find the acceleration of a particle when time is equal to 1. Okay, the acceleration of a particle when time is equal to 1. So acceleration, again, it is the change of velocity, okay, which is change of distance. First of all, velocity is the rate of change, okay, of distance with time, okay. Then the rate of distance twice the rate of distance, okay, then that becomes the acceleration. So acceleration is the rate of change of velocity with time, which is dv over dt. Now this is acceleration, okay, dv over dt, which is d2s over dt squared. Okay, now this is the formula for acceleration. So what we need to do is we need to take the derivative of the velocity to find the acceleration. Okay, so here we know that the velocity is minus 4t plus 1. Okay, so minus 4t plus 1. So d over dt of minus 4t plus 1. Okay, this will be minus 4. Okay, so the velocity is minus 4 meters per second squared. Okay, again, not the velocity, the acceleration is minus 4 meters per second squared. Again, looking at the sign, meaning the particle is decelerating. Of course, when you visualize, you look at the graph, this particle is decelerating. Okay, it is accelerating from this side to this side, and it is decelerating. Okay, so time is equal to 1. The acceleration will be minus 4 meters per second squared. Okay, then find the time traveled when the distance is equal to 0. Okay, find the time traveled when distance is equal to 0. So s of t is equal to minus 2t plus t plus 1. Now find the time. Find the time when distance is equal to 0. So minus 2t squared plus t plus 1 is equal to 0. So now from here, t is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. B is 1, so minus 1 plus or minus square root of again b is 1. Okay, 1 squared minus 4, a is minus 2, c is 1. okay? C is 1 over 2 over minus 2, because A is minus 2. So minus 1 plus or minus square root of, what do we have? 1 plus 8 over, that is minus 4. So minus 1 plus or minus square root of 9 over minus 4. This is equal to minus 1 plus or minus square root of 9, which is 3, okay? 3 over minus 4, okay? So time will be either minus 1, time will be, oh jeez, how am I gonna write this? Minus 1 plus 3 over minus 4. That is, what is that? That is 2 over minus 4. That is minus half. Minus half. Then when it is when we take negative, or t is equal to minus 1 minus 3 over minus 4. This will be minus 4 over minus 4. This is equal to 1. So time can never be negative, so we are going to take the positive one, okay? So when the distance is equal to 0, time is 1 second, okay? Which I found the other time. So when the distance is 0, time is 1 second. Yeah. So these are some of the things, you know, the application of of calculus. I mean, the simple calculus. I mean, in one dimension. Those will be the applications. Okay. Yeah. There's lots of things to do. So I just wanted to make a very simple video. I mean, not something complicated. Just to touch base. Okay. All right. Have a nice time.